All right. In part two of our studies, we learned about rational functions. And rational functions are really just functions that are fractions. So in the beginning, we talked about simplifying rational functions. And we can simplify, um, we've done simplifying of just basic monomial functions, which is the first example, 3x to the 7th over 6x to the 4th. And you've done this a variety of ways and with more or just one variable. And basically, it's just the same as it was in Algebra 1. If we're going to simplify 3 over 6, a number that goes into both 3 and 6 is 3. It goes into 3 one time. It goes into 6 two times. And then in terms of our variables, we have 7x's on top because of this 7. And we have 4x's on the bottom. And so all the x's on the bottom will cancel out because there are fewer of them. And we will be left with 3x's up top. So this becomes 1x to the third over 2. Now we quickly went on to go ahead and look at a little bit more complicated things. And first we started when they were already factored for us. And we said we were allowed to go ahead and cancel factors that occurred in both the numerator and the denominator. So in this problem right here, this x minus 3 times x plus 6 over x minus 3, it's being factored for us. We know that because of those parentheses. And we're allowed to cancel x minus 3's because they occur in the top and the bottom. And that would leave us with just x plus 6 as an answer. Now it says, give us any values for which the expression is undefined. Well, if ever we have an x in the bottom, we cannot have that ever turn into 0. So in this case, because we started with x to the 4th in the bottom, none of those x's can equal 0, so x cannot equal 0 there. In this problem, we have x minus 3 in the bottom, and we know that x minus 3 cannot equal 0, which if we add 3 to both sides tells us x cannot be 3. All right, go ahead and stop the video, pause the video, and then try the next two problems yourself. All right, so I have the answers below, the two problems below. In the first problem, you should have seen that 7 goes into both 14 and 21, and so therefore goes into 14 two times and 21 three times. And we can cancel the y's on the top with the y's on the bottom, and there are more on the bottom. That's why there is a y left in our answer. But there's nothing to cancel the z's with, and there's nothing to cancel the x's with, so those remain in the problem. For the next problem, you actually have to factor. And so I factored the numerator, numbers that multiply to -3 and add up to -2. And I factored the denominator, numbers that multiply to 4 and add up to 5. And as we see, the x plus 1's are able to cancel. So that means the leftover x minus 3 over x plus 4 is our answer. But we do need to eliminate numbers that would make the denominator 0. In this case, -1 would make the denominator 0, and so would -4. And in this problem, we can't have x or y cannot equal 0 because those are both in the denominator. All right, so moving on. After we started simplifying with rational functions, we moved directly on to multiplying with rational functions. This was very similar to simplifying, except now we had more things to cancel. And there you are allowed to cancel terms that are in the numerator of one fraction with terms that are in any denominator, and vice versa, terms that are in the denominator with any terms that are in the numerator. So for example, when I'm doing the first problem, I have a 2 up here and an 8 down here, and I should know that 2 goes into both of those. So this 2 will go away, and this 8 will become a 4. And then now I can look at the x's. So I have 4 x's up here, and I have 3 x's down here, or I have 2. I can cancel with any of those. I also have 2 x's up here, x squared, and an x squared down there. So I'm actually going to cancel those all in one go. And now I'm going to say that these 4 and these 3 will cancel. These 3 go away, and that leaves us with just 1x up there. And then I'm going to go ahead and do the y's. So that I have 5 y's up top, and I have 2 y's down below. So all of those y's will cancel out, and that will leave us with just 3 y's up top. And then finally, I have a 15 and a 3. 3 goes into both of those. 3 goes into 15 5 times. So if I multiply what I have left over, up top, I have a 5, I have an x, and I have y to the third. And on the bottom, I have just a 4 and nothing else. So that's what I have. All right, we also did this when they were already factored for us. That was the next easy step. And if you want to go ahead and try that, pause that one with the video and try that one. Okay, so as you can see, because it was already factored for us, it was easy to see the factors that cancel. The x minus 6 is canceled, the x minus 2 is canceled, and the 6 and 12, they both have 6 in them. And what we would have left over would just be x plus 3 over 2. All right, moving on to the next problem, I actually have to factor that first in order to see what's canceled. And I know I have to do that because there's no parentheses. And I can't cancel things that aren't factors. And a big clue to you is going to be if there are no parentheses, then it's not factored. So I'm going to go ahead and rewrite this first. So the first fraction has 10x minus 4p, right? And those aren't squares or anything, but everything has you have to check to see if it has a greatest common factor, which they do have. So I'm going to take out 10 because that goes into both of them, and I end up with x minus 4. That's what the top becomes. In the bottom, it's a trinomial. I know that because there's 3 terms. So I need 2 numbers that multiply to 8 and add up to negative 6. And hopefully you know that's negative 4 times negative 2. So that's x minus 4 times x minus 2. All right, next fraction, x plus 3 has no greatest common factor there, so I can't take anything out. But in the bottom, they both have a 5, and that becomes x plus 3. All right, so let's cancel what we have. We have an x minus 4 up top and bottom. We have an x plus 3 up top and down below. And then the 10 and the 5 that are left, 10 and 5 both have 5 in them. 10 has it in 2 times, and 5 has it in once. So what do we have left over? Well, in the top, all there is a 2. And in the bottom, there's just an x minus 2 times 1, so we don't need to write that. And this would be our answer for that one. Go ahead and pause the video and do the last problem and then come check your answer. Okay, hopefully you guys were able to see that in the bottom of the first fraction, you can take out a greatest common factor of 3. And in the bottom of the second fraction, this is a difference of squares. It's really important that you can recognize a difference of squares. Each term is a perfect square, and they are subtracting, which is what this is. So it factors into x plus 2, x minus 2. And then once we cancel out our common factors, we have nothing left in the top, so we have to have a top. So we call it 1. And in the bottom, we have 3 times x minus 2. All right, let's move on. Okay, the next thing that we did was we divided fractions. And dividing fractions was really similar to multiplying fractions. All we had to do was change the division sign into a multiplication and then flip the sign that came after it. And you've done that your whole life when you've done things like 1/2 divided by 3/4, for example. We would turn that into 1/2 times and we would flip that second fraction 4/3. And that's how we would go ahead and solve that problem. So the first problem, it's almost completely factored except the top of the first fraction. And since the first fraction stays the same, I'm going to go ahead and factor this right as it is. X plus 1 times x minus 1. And hopefully you recognize this because x squared is a perfect square, 1 is a perfect square, and x squared minus 1 is a difference of squares. So x plus 1 times x plus 3. All right, and so then I'm going to change this to a multiplication sign, which makes the other fraction flip. X plus 4, x plus 3 over x minus 1, x plus 5. All right, once it's already in factored form and turned to multiplication, we're allowed to start canceling. So I can cancel out the x plus 3's. I can cancel out the x minus 1's. And I can cancel out the x plus 1's. And for my answer, on the top, I have x plus 4. And on the bottom, I have x plus 5. All right, why don't you try the second problem? And don't forget to start by simplifying as well as flipping. All right, so hopefully you factored x squared minus 9. It's a difference of squares into x plus 3, x minus 3. and then the bottom was already factored. And then I changed the symbol to multiplication, which allowed me to flip the other fraction. X squared minus 16 is also a difference of squares, so x plus 4 times x minus 4, and the bottom was already factored for us. Then I canceled out the plus 3's, the plus 4's, and the minus 4's. And what we have left over is x minus 3 times x plus 2. Over x plus 2. All right, the next problem is really similar. It just needs a lot more factoring. This one has difference of squares and trinomials. So I'm going to go ahead and factor those. So up top we have we have a trinomial. So I have two numbers that multiply to negative 12 and add up to negative 1. And those numbers are negative 4 times 3. And so the first one factors into x minus 4 and x plus 3. The bottom is x squared minus 9, which is a difference of squares, which turns into x plus 3 times x minus 3. All right, I'm going to change that division sign to a multiplication sign. That means I'm going to flip the fraction. So this x squared minus 4 is going to come up top. X squared minus 4 is a difference of squares, which is x plus 2 times x minus 2. And on the bottom, we have another trinomial. So we want two numbers that multiply to negative 8 and add up to negative 2. So those are negative 4 times 2. And so that would be x minus 4 and x plus 2. And so we're going to go ahead and cancel all the common factors. So I see x plus 3's, I see x plus 2's, and I see x minus 4's. And so what we have left over on the top is x minus 2, and what we have left over on the bottom is x minus 3. And that would be our answer. Okay, go ahead and pause the video again and try the last problem. Okay, so hopefully you saw that we can factor the x squared minus 16 is a difference of squares, so is the x squared minus 9. I changed the symbol to multiplication. Then I did two trinomials, the x squared minus 5x minus 6. At first I actually got it wrong. I thought it was negative 6 and 5, but it's actually negative 2 and negative 3. They multiply to 6 and add up to negative 5. And then the bottom, two numbers that multiply to 8 and add up to negative 6 are negative 4 and negative 2. All right, that when we cancel everything, it leaves us with x plus 4 over x plus 3. All right, from there we went on and added and subtracted rational functions. And in order to do this, it was all about the denominators. If the denominators were the same, it was really easy. If the denominators were not the same, it was a little bit harder. So I'm going to do the ones on the left-hand side, and I'm going to need you to do the ones on the right-hand side. First, you check those denominators. If they're the same, which they are here, that means it's going to be x plus 5 in your answer. And the numerators, we can just go ahead and do whatever operation we're asked, which in this case is minus. So I'm going to do x minus 8x, which is negative 7x. And negative 6 minus 7 is basically negative 6 plus negative 7, which is negative 13. So that's the answer I got for that. Go ahead and pause and do the next problem. All right, you should have gotten the answer negative 3x minus 5 over x squared plus 1, and you can see my work below. All right, the next problem, we look at them and they're not the same denominator. So I'm going to go ahead and factor this denominator on the right. So 4x over, this is x plus 3 times x minus 3. Now, if you see the one that's on the left, the 2 over x plus 3, it almost has the same denominator, but it is missing the x minus 3's. So what we did then was to make it have the same denominator. We said, all right, if whatever it's missing, which in this case is x minus 3, that's what we're going to go ahead and multiply the top and the bottom by so that it will become the same. So if we do that, then that first fraction, 2 times x minus 3, now gets the same exact bottom, x minus 3x plus 3 plus 4x over x minus 3, x plus 3. Once the bottoms are the same, you can do what we did for the top. So I'm going to go ahead and distribute this 2. This becomes 2x minus 6. Don't forget to distribute it to the 3. And then I'm going to add the 4x to it. And now they have the same bottom, x minus 3x plus 3. And if I go ahead and combine my like terms there, 2x and 4x is actually 6x minus 6 all over that bottom, x minus 3x plus 3. All right, so go ahead and pause the video and try the next problem. All right, you should see from the next problem that the denominator over here for the 8 could be factored into x plus 2x minus 2. And so the one on the left is just missing the x minus 2's. So we went ahead and multiplied the top and bottom by that. And when you multiply x times x minus 2, you get x squared minus 2x. And then if you add the negative 8, then you are done. All right, very last problems on this page, in this group, I mean. They are ones where the denominators are completely unlike. And in this case, like x plus 1 and x plus 4, there's nothing to factor. They have nothing in common. So what we actually ended up doing was we multiplied the fraction on the right by the denominator of the fraction on the left. So we gave it the x plus 1's that it was missing. And on the left, we gave it what it was missing, which was the x plus 4's. All right, that says x plus 4. All right, so when we do that, on the left, we end up with x times x plus 4. And on the right, we end up with 3 times x plus 1. And now, there I'm going to go ahead and put them over the common denominator, which is x plus 1 times x plus 4. So all we need to do now is kind of clean up. X times x plus 4 is x squared plus 4x. I distributed that. And the other one is plus 3x plus 3 all over x plus 1 times x plus 4. And once again, we can combine those like terms in the middle there. 4x and 3x is 7x. So we have x squared plus 7x plus 3 all over x plus 1 times x plus 4. All right, go ahead and pause that video one more time, and you can do the one on the right. All right, so as you can see, I went ahead and multiplied the numerator and the denominator by what we were missing, which in this case on the left was the x plus 3's and on the right was the x minus 2's. Up top, I had to distribute, so 6 times x plus 3 gave me 6x plus 18. And don't forget, this is actually a negative 3 times x minus 2, and that's why I ended up with a plus 6 on the end here. And when I combined like terms, I got 3x plus 24. All right, last problem. All right, the very end of our graphing rational functions unit had all of those things that we talked about: domain, vertical asymptotes, holes, x-intercepts, y-intercepts, and horizontal asymptotes. But before we were able to find any of those, we had to take whatever our function was and we had to factor it completely. So at the top we have a trinomial. We want two numbers that multiply to negative 16 and add up to negative 6. And if you think back, you can multiply negative 16 and get as 8 times 2. So 8 times 2, one of them has to be negative. In this case, it's the 8. So that would be x minus 8 and x plus 2. And on the bottom, it's a difference of squares, x minus 2, x plus 2. Now, hopefully you see that the x plus 2's will cancel. Before we do that, though, we find out our domain. And our domain is the opposite of the numbers in the bottom, because that's what x cannot be. So x cannot equal 2 or negative 2. And that's because of the numbers in the bottom. Okay, now to find our vertical asymptotes, we go ahead and cancel. So we're going to cancel out those. Vertical asymptotes come from whatever is left in the bottom. So this is left in the bottom. And what number would make that 0? 2 would make that 0. So our vertical asymptote is x equals 2 because that is the number that's left in the bottom. So that's the line I'm going to go ahead and add to my graph. That's my vertical asymptote. Vertical asymptote. It's a line. Asymptotes are lines, and a hole is just a dot. The hole comes from the term that I canceled. So I canceled x plus 2's, which means my hole is at -2. It's always the opposite of those numbers. Okay, well, how do I find the y value? Well, I take -2 and I plug it into what's left over. So -2 minus 8 over -2 minus 2. If I take -2 minus 8, I get -10. -2 minus 2 is -4. And if I divide these, I get 2.5. That is where my hole is, at -2, 2.5. So I'm going to go over to -2, and I'm going to go up to 2.5, and I'm going to put a hole. My x-intercept is wherever the numerator would equal 0. So where would my numerator equal 0? And that would happen at +8, because x minus 8 equaling 0, if I add 8, that's where it's going to happen, at +8. So my x-intercept is at 8, 0. Literally over here at 8 and 0. My y-intercept is what happens when I plug in a bunch of zeros for all the x's. So 0 minus 8 over 0 minus 2. Or I could have done that to the original problem. I think I used to go back and plug in zeros for the original problem. It will give us the same answer either way. It will give us +4. So my y-intercept is at 0, 4. All the way up here, 4. My horizontal asymptotes had to do with top heavy and bottom heavy. And if we look back at the original problem, they were both x squareds. So they were both equal weight. And when they were equal weight, we took the numerator of the top and the bottom and divided it. So in this case, they were both 1x squared. So 1 divided by 1 is 1, which means that we have a horizontal asymptote here at 1. Horizontal asymptote. And so if we look on our calculator and we go ahead and put it in our calculator, what happens is we get a graph that looks like this. Now, is it discontinuous? Yes, it's discontinuous because it has any kind of a hole or vertical asymptote. If it has any of those things, then it's discontinuous. All right, well, that was rational functions. I hope that was a good review.